So now firstly I will explain you the Python code of k-means clustering algorithm. So here in this example I have used the iris dataset. I have not externally imported any iris dataset. I have used the Seaborn library which has the inbuilt datasets in it. So firstly we will import all the libraries required, that is import numpy as an np, import pandas as pd, import matplotlib.pyplot as plt. From sklearn.cluster import k-means, this is the main library, and import seaborn as sns. I have used here seaborn just for the data set. So now in seaborn we have various data sets as you all can see here. So just write this line and we will be able to see the datasets present in this library. So the code is sns.get dataset names. So after typing this and running, we will get all the datasets present in the Seaborn library. So I want to use iris. So yes, I can see the iris dataset. So now we will load this iris dataset and store the data in the data frame df. After populating the data frame df, we will use the head method on the dataset to see its first 10 records. So now after implementing this, we can see our dataset over here. We have top 10 datas and we have sepal length, sepal width, petal width and species. Now we'll select all four features, that is sepal length, sepal width, and petal width of the dataset in a variable called x, so that we can train our model with these features. Now for this we will use the iloc function on df and the column index 0, 1, 2, 3 for the above four columns used. So the code is x is equal to df.iloc colon 0, 1, 2, 3 dot values. Now to start, let's arbitrarily assign the value of k as 5. Now firstly, as we have studied in the presentation, that we have to, in first time we have to assign the number of clusters by our own. So we are taking over the number as 5 here, and now we will implement the k-means clustering using k is equals to 5. Now we will use the variable k-means 5 and assign the k-means clustering algorithm to it. So the code is k-means 5 is equal to k-means whole bracket n clusters is equals to 5. So n clusters here is the variable for the number of clusters we are going to use. Now y k-means 5 is equals to k-means 5 dot fit predict x. And then we will print the y k-means 5. Now we can see the output over here. We got the output as 1, 2, 3, 4, 0, 4, right? So this is the cluster data, and now for getting cluster centers, we will write k-means 5 dot cluster centers. So after running this, we will get the output in the array format, and we will get the all cluster centers. Now, there is a method called the elbow method which is designed to help find the optimal number of clusters in a dataset. So let's use this method to calculate the optimum value of k. To implement the elbow method, we need to create some Python code as shown below now over here. So, and then we will plot a graph between the number of clusters and the corresponding error value. This graph generally ends up shaded like an elbow. See over here we can see. Firstly we will see the code. So the code, firstly we will initialize the empty list named error. Then using the for loop from 1 to 11, we will write k-means is equals to k-means n clusters is equals to I dot fit x, k-means dot fit x, error dot append k-means dot inertia. After this, we will append all the values which we will get from this for loop. Then we will import matplotlib again, and then we will plot the outputs which we get from this for loop. And we will give y label as error over here, cy axis, and x axis will be named as number of clusters, and the title of the graph will be elbow method, and plot.show will plot the graph and show us as the output. So here we can see the graph, and yes, we can see the elbow shape in the graph over here at 2, right? 2 and between 2 and 4. So now, as we can see, the optimal value of k is between 2 and 4 because we got the shape of elbow between 2 and 4. So the elbow-like shape is formed at k is equals to 3 in the above graph. So yes, it is right. We got the elbow shape at k is equals to 3. It means now we will have to implement the k-means algorithm using k as 3. So now we will implement it. K means 3 is equals to k means n clusters is equals to 3. Y k means 3 is equals to k means 3 dot fit predict x print y k means. So now again we will get an array and then k means 3 dot cluster dot centers we will get the centers, that is centroids. And now finally it's time to visualize the 3 clusters that were formed with the optimal k value. So we will use the code plot.scatter x colon 0 x colon 1 comma c is equals to y k means 3 c map is equals to rainbow. C map is equals to rainbow is used just for the colors in the clusters to visualize various clusters. And yes, we can see the clusters finally over here. We have got the 3 groups of clusters different. And finally, we have used the k-means algorithm successfully. So in short, I'll just explain you. Firstly, we have taken the number of clusters as 5. Yes, as 5. And then we have found out the cluster centers. Then later using the elbow method, we got the right number of clusters we have to use. That was 3 as it was showing the elbow on the 3 in the graph. Then we used 3 and we got perfect clusters and then we stopped the iteration and run the k-means algorithm successfully. Now I will explain the Python code of hierarchical clustering. So the question first is why hierarchical clustering? So we should first know how k-means works before we dive into hierarchical clustering. So firstly, before understanding what is hierarchical clustering, we must know what is meant by k-means clustering in short, and I have explained you, but still I'll explain you in short. So k-means clustering steps are decide the number of clusters, then select k random points from the data as centroids, then assign all the points to the nearest cluster centroid, calculate the centroid of newly formed clusters and repeat the steps 3 and 4. We have seen this now only previously in the presentation and I have also explained you the example. We know that it's an iterative process. It will keep on running until the centroids of newly formed clusters do not change or the maximum number of iterations are reached. But there are certain challenges with k-means. It always tries to make clusters of the same size. Also, we have to decide the number of clusters at the beginning of the algorithm. Ideally, we would not know how many clusters should we have in the beginning of the algorithm and hence it is a challenge with k-means. So here we can say that hierarchical clustering is a solution to the problem with the k-means clustering. So this is the gap hierarchical clustering bridges with aplomb. It takes away the problem of having to predefine the number of clusters. Right, so hierarchical clustering removes the problem of k-means clustering that we do not have to predefine the number of clusters in hierarchical clustering. Now in short, let's see what is hierarchical clustering. So let's see, these are the clusters and now we can assign each of these points to a separate cluster. So these are the points and now we have assigned these colorful clusters to these points. Now based on the similarity of these clusters, we can combine the most similar clusters together and repeat this process until only a single cluster is left. We are essentially building a hierarchy of clusters. That's why this algorithm is called hierarchical clustering. I will discuss how to decide the number of clusters. Now we will see further. Now I have explained you about the agglomerative hierarchical clustering. See, there are number of clusters and they are grouped into one. And in divisive hierarchical clustering, it's opposite. All data is just there in one cluster and then later it is divided into many clusters. Now steps to perform hierarchical clustering. We merge the most similar points or clusters in hierarchical clustering. We know this. Now the question is, how do we decide which points are similar and which are not? It's one of the most important questions in clustering, right? Now here one way to calculate similarity. Take the distance between the centroids of these clusters. See, we have used the Euclidean distance in k-means algorithm. Now here let's see what we have to do. The points having the least distance are referred to as similar points and we can merge them. So here the similarity is based upon the distance. Less distance between the points means they have the similarity. We can refer to this as a distance based algorithm as well. Right, because since we are calculating the distances between the clusters. Now in hierarchical clustering, we have a concept called a proximity matrix. This stores the distance between each point. Let's take an example to understand this matrix as well as the steps to perform hierarchical clustering. Okay, so now let's see an example. Suppose a teacher wants to divide her students into different groups. She has the marks scored by each student in an assignment, and based on this mark, she wants to segment them into groups. There is no fixed target here as to how many groups to have, since the teacher does not know what type of student should be assigned to which group. It cannot be solved as a supervised learning problem. So we will try to apply hierarchical clustering and segment the students into different groups. So now this is the student ID and marks, and we have 5 students. This 5 students and 5 students marks are given over here. Now we will create and understand what is meant by proximity matrix. So firstly, we will create a proximity matrix which will tell us the distance between each of these points. Since we are calculating the distance of each point from each of the other points, we will get a square matrix of shape n into n, right? Because we are calculating the distance of every student from every other student. So every student will get the distance from every other student and we will get 5 into 5 matrix over here. Yes. So we got the proximity matrix over here. The diagonal elements of this matrix will be 0 as the distance of a point with itself is always 0. Yes, distance of first student from first is 0 only. Second from second will be 0. Third student from third will be 0 and so on. So now we will use the Euclidean distance formula to calculate the rest of the distances. Wow. So it means that we use Euclidean distance in both algorithms, that is k-means clustering as well as hierarchical clustering. So now this is the formula. I have discussed the formula in the presentation also. So using this formula we got the 3. Now similarly we can calculate all other distances and fill the proximity matrix. So I hope you understand the proximity matrix. It's very simple. It's just the distance calculated between the two students and the distance is written in this matrix. Now we will understand the steps to perform hierarchical clustering. Step 1. First we assign all the points to an individual cluster. Okay, so firstly every data is assigned a different cluster. Different colors here represent different clusters. You can see that we have 5 different clusters for the 5 points in our data. For example, we have this 5 data points and we have this 5 number of clusters. Now step 2 is we look at the smallest distance in the proximity matrix and merge the points with the smallest distance. We then update the proximity matrix. Okay, now as we have seen in the above example, here also we have 5 data. So we will calculate the distances of each data from each other data and we will create the proximity matrix. So for this data we have the proximity matrix like this, and now based on the smallest distances between two data we will merge them. So here the smallest distance is 3 and hence we will merge point 1 and 2. So now here 1 and 2 is having the less distance, so we will merge 1 and 2. So here you can see the change in the color. Firstly we had 5 clusters: green, orange, light green, pink and blue. Now we have only 4 clusters. See, 2 is also converted in cluster number 1. So we have now only 4 clusters, that is blue, green, orange and black. Now let's look at the updated clusters and accordingly update the proximity matrix. So firstly we had 5 columns, now we have only 4. See, 1 and 2 is merged. Now here we have taken the maximum of the 2 marks 7, 10 to replace the marks for this cluster. Instead of the maximum, we can also take the minimum value or the average values as well. Now we will again calculate the proximity matrix for these clusters. So for in first data we had 5 students, so we created the proximity matrix for that 5 students. Now we merge the 2 students. Now we have only 4 students. Now for 4 students, we will have 4 into 4 matrix. So the matrix is over here. Now we will repeat the step 2 until only a single cluster is left. Okay, so now we will repeat. It's an iterative algorithm. We will repeat the step C. First we had only one blue, then we merged this 2, then we merged this 2, 4 and 2, then we merged 3 and 5, and in this way we got one cluster at last. We started with 5 clusters and finally have a single cluster. This is how agglomerative hierarchical clustering works. Now, the question here is how we decide the number of clusters, right? How should we choose the number of clusters in hierarchical clustering? So just let's understand how to do that. So to get the number of clusters for hierarchical clustering, we make use of an awesome concept called a dendrogram. So now, yes, we have heard this concept in presentation. We have even seen that I have explained you, but let's see here. It's given in detail. Now, a dendrogram is a tree-like diagram that records the sequences of merges or splits. Okay, now we will get back to our student and teacher example, which we have seen now. Whenever we merge two clusters, a dendrogram will record the distance between these clusters and represent it in graph form. Let's see how a dendrogram looks like. Now, so first this is the graph. Now we have the samples of the data set on the x-axis and the distance on the y-axis. Whenever two clusters are merged, we will join them in this dendrogram, and the height of the join will be the distance between these points. Let's build the dendrogram for our example. Now I have explained you this. Now we will see the dendrogram for that. So firstly we have merged this 1 and 2. So now we will merge this 1 and 2. So similarly we will merge everything and we will mark it on the graph. So finally we will get this dendrogram for that 5 students example. We can clearly visualize the steps of hierarchical clustering. More the distance of the vertical lines in the dendrogram, more the distance between those clusters. Now we can set a threshold distance and draw a horizontal line. So let's set this threshold as 12 and draw a horizontal line. So here now we have set the threshold at 12 and draw the horizontal line. Now the number of clusters will be the number of vertical lines which are being intersected by the line drawn using this threshold. In the above example, since the red line intersects two vertical lines, we will have two clusters. One cluster will have a sample 1, 2, 4 and the other will have the sample 3, 5. Yes, see, this vertical line is intersecting two lines, and this line consists of 3 points, that is 1, 2, 4, and this line consists of 2 points, that is 3 and 5. So this is how we can decide the number of clusters using a dendrogram in hierarchical clustering. Now let's see the Python code for hierarchical clustering. So in this I have used an external data set, that is wholesale customers data. It's a CSV file. I have loaded it in the files section. Now firstly we will import the libraries. So what is this example about? Let's see that. So we will be working on a wholesale customer segmentation problem. And this data, the aim of this problem is to segment the clients of a wholesale distributor based on their annual spending on diverse products like milk, grocery, region, etc. Okay, so now firstly we will import the libraries, import pandas as pd, import numpy as np, import matplotlib.pyplot as plt, and mod matplotlib inline. Now we will load the data. For loading the data, we will write the code data is equals to pd.readcsv wholesale customers data.csv, and then we will read the top 5 data from the data set. And we have here, we can see the 5 data set. We have channel, region, fresh, milk, grocery, frozen, detergents, paper, delassican. Now there are multiple product categories. Yes, like fish milk, we have seen it. The value represents the number of units purchased by each client for each product. Our aim is to make clusters from this data that can segment similar clients together. So now we will use the hierarchical clustering algorithm for this problem. So firstly, our aim is that we must normalize the data before using it. Here the data is very different from each other. The numbers here, it's 12,669. Here it is 1,762. So it's difficult for the machine to understand. So we will normalize all these data between 0 to 1. See here, as you can see, I have normalized each data in the form between 0 to 1. So for normalizing the data on the same scale, we will use this code from sklearn.preprocessing import normalize. We will import the library normalize function normalize from the library sklearn.preprocessing. Then we will use the variable data scale to normalize the data. Data scaled is equals to pd.dataframe data scaled comma columns is equals to data.columns and data scale dot head. So here we can see all the data is normalized now. This was the real data and now we have normalized it to in the form between 0 to 1. So now here we can see that the scale of the variables is almost similar. So now we will draw the dendrogram first to decide the number of clusters. So for that, import scipy.cluster.hierarchy as shc, plot figure fixed size 10,7, plot title dendrograms, dend is equals to shc.dendrogram, shc.linkage data scale method var. So using this code, we will get this output. We will get a dendrogram as we have seen above also. So the x-axis contains the samples and y-axis represents the distance between the samples. The vertical line with maximum distance is the blue line and hence we can decide a threshold of 6 and cut the dendrogram. So here in the previous above we have seen that we got the threshold of 12 because the large line was this, so threshold was 12. Similarly here the large line is from 6 to 12, so threshold we can take over here is 6. So now from sklearn.cluster import agglomerative clustering. Cluster is equals to agglomerative clustering and clusters is equals to 2 affinity Euclidean. We are using Euclidean distance and linkage var. Then cluster.fit predict data scale. So here we get the array of 1 and 0, 0 and 1. So we can see the value zeros and ones in the output since we defined two clusters. 0 represents the points that belong to the first cluster and 1 represents point in the second cluster. Let's now visualize the two clusters. Here we got two lines, right? So we decided to take the number of cluster as 2. So the data is divided now into two clusters here in the form of 0 and 1, and now we can visualize the data and number of clusters using the matplotlib. So here the code is plot.fix size 10,7. This is the figure size which we want, and plot.scatter data scale milk, data scale grocery, and c is equals to cluster.labels. So this is our final clusters. We have divided the data into two clusters using hierarchical clustering algorithm. So this was all. I hope you liked my video. I will upload more videos soon. Thank you.